The content in this video will be showed how to calculate and make a shunt for ammeter, step by step in details. This is a DC current meter with maximum 50 amperes capacity. In fact, it needs to attach a shunt to operate correctly. Let us measure its internal resistance by using a multimeter's ohm position. The meter indicated 6.4 ohms, the actual figure was 6.3 ohms, because of the multimeter's small error. This setup is for measuring the DC current meter's maximum current flow when its needle in full scale position, and its ampere figure will be showed on the multimeter. The setup circuits diagram is here. A 1.5 volt battery installed in the black box. The DC current meter is here. The multimeter is there, and has been selected to milliampere position. There is a 300 ohms adjustable resistor there, for controlling the circuit's current flow. Whole circuit is connected in series, and 2 meters connected side by side. Turn the battery on. The DC current meter's needle moved to 1/3 of its scale, and the multimeter indicated 3.3 milliamperes. Then adjusting the resistor made the needle move to center of its scale. The multimeter indicated 5.3 milliamperes. Continuing adjusting until the needle reached its full scale, the multimeter indicated 12 milliamperes, which means 50 ampere indicated by the DC current meter if it had a proper shunt attached. The numeral numbers marked on this meter's scale are for the amperes figure with a proper shunt attached. Let us draw a simple circuits diagram. The square with an A inside represent the DC current meter, and that is for its internal resistance as R. This resistor is for a proper shunt connected as R of a capital letter. The current from left marked as a capital letter I. The current goes through the DC meter marked as IR. The current goes through the shunt will be I subtract IR. Looking at the voltage between the ends of 2 points, because of VR equals IR times R. VR the capital of R, which is the voltage between the ends of the shunt, equals I subtract IR, brackets, times the capital of R. As V small r equals V capital of R. Then, I smaller times small r equals I subtract I smaller brackets times capital of R. The capital of R equals, denominator is I subtract IR, brackets. The numerator, which is above the line is I, small r, times, small r, equals. By taking out I, small r from inside brackets, so the below line. I over, I, small r subtract 1, brackets times I, small r. Above the line. I, small r times, r equals, small r over. Bracket, I, divided by I, small, r, subtract, 1, bracket. This is the formula to calculate the resistance for this meter's shunt. In fact, the formula can be for any DC current meter's shunt resistance calculation. Let me rewrite the common formula here. The shunt resistance capital R equals R over capital I divided by I, small, r subtract 1. As we have already known, R equals 6.3 ohms, I, small r, equals 12 milliamperes. I, which is for the amperes on the meter's full scale, equals 50,000 milliamperes. Filling all the figures into the formula, the shunt resistance R equals 6.3 ohms over 50,000 milliamperes divided by 12 milliamperes. Then, subtract 1 equals 6.3 ohms over 4,166.7. Subtract 1 equals approximately 0.0015 ohms equals 1.5 milliohms. This is the resistance of a proper shunt, which connects to the meter. Now it's time to make a proper shunt. The material like this can be made for a 1.5 milliohm shunt by using a milliohm meter to measure, then adding a couple of ring connectors. Finally a few tries to get thing done. However, I have a shunt, which its own value higher than 1.5 milliohms, and it can withstand more than 50 amperes. All I have to do is to find out the point, which will be the 1.5 milliohms between two connection points. I reckon it'd be along here. This setup is for finding out the correct point on that shunt. The red cable is from an adjustable DC power positive, followed by the DC current meter with the shunt connected, through a multimeter's ampere function, then the black wire connected to a bulb as a load, finally connected to the power negative. Switch the power on, then adjusting the power and bulb lighten, the multimeter indicated 3.6 amperes. Adjusting the power to make 5 amperes output, 4.99 amperes was close enough indicated by the multimeter. However, the DC current meter showed about 8 amperes. Now adjusting the thin black wire position on the shunt to make it as 5 amperes. Just about here. 5 amperes. Switching the DC power off. A hole will be drilled here, for the proper connecting point, the similar to the one near at the top end. A newly drilled hole is here. It proved to be the location much accurately than previously by tried a few more times, for varies of amperes such as 10, 20, 30 and 40 amperes. The end of the thin black wire will be secured on the hole newly drilled. Then the meter and shunt together will be installed on this DIY made wood board. All done. The meter has been installed into a center hole made. Its shunt installed on the back of the board. 3 of these screws secured the shunt on the back of board. The end of the thin red wire from the meter secured by a smaller screw on the shunt, and so did the black wire from the meter on the shunt. The bigger bolt and nut on the shunt from right will be for positive circuits connecting, and so negative will be from left. The setup has been done for the final test, beginning with battery. The red cable from battery's positive goes through the DC current meter just made, continuing through the black cable to a solenoid as a load, then through white and red wires combined to the ampere meter. Finally, black cable from the ampere meter to battery's negative terminal. The figure from the ampere meter indicated is the same as the DC current meter's needle indicated. The proper shunt has been made with this DC current meter. Remember the calculation formula for the shunt's resistance. Thank you for watching. Please like, share, comment, and subscribe if you have enjoyed the video. Your encouragement is my motivation.